Good afternoon. My name is Parker Lusk, and today I'm going to be talking about the effects of cryogenic aging on the modulus of elasticity of thin film polymers. Before I get started, I want to give you a little bit of a background into what we're going to be talking about today. Cryogenic polymers have a variety of applications. They're used in computer chips, superconducting quantum interference devices, also called SQUIDs, and linear particle accelerators like the one at Oak Ridge National Lab. There are two commonly used types of polymers here. One are called liquid crystalline polymers, such as Vectra or ULTRALAM, and another kind are called Polymides. Examples of those are Kapton and Lux. So now I want to talk about some of the goals of this research. My research and work is done with a larger interdepartmental group composed of mechanical, electrical, and chemical engineers. The main research goal is to look at the effects of thermal cycling on these polymers. My specific focus will study on the elastic modulus of one specific linear liquid crystal polymer, ULTRALAM 3850HT, cut in the machine direction. So what is the modulus elasticity? It's essentially a material's resistance to being deformed. It's also called Young's modulus. The modulus is calculated by taking data from a stress-strain curve, which is shown here in this figure. And a stress-strain curve is generated by taking a sample and loading it into a load frame, here an ADMET expert, and then pulled on at a set displacement rate. So the modulus is calculated by taking the stress, which is the force per area, almost like a pressure, but in reverse, divided by the strain, which is the change in length divided by the total length of the sample. And then it'll generate a graph that looks something like this. What we're looking for in this graph is this linear region here, and that's what we call the elastic region. The elastic modulus is the slope of that linear region. So the motivations behind this study is a work done by Mark Davidson and his team from Fermi National Lab. They measured the elastic properties of Kapton for use in superconducting supercollider magnets. But there are a few key differences in David's study versus my own. Davidson and his team measured perpendicular to the plane of the film, whereas my study measured parallel to the plane of the film. Davidson's team studied Kapton, which is a polyimide, while I studied ULTRALAM, which is an LCP. And finally, Davidson and his teams tests were conducted at a cryogenic temperature, while mine were conducted after cryogenic aging. So now I'm going to move into talking about my actual data and results. Before I could run any actual tests with my age samples, I needed some control data. So here's a graph of my control samples. As you can see, I ran 6 samples that have an average modulus of 3,200 megapascals with a standard deviation of about 342. This is what is to be expected as the reported modulus for ULTRALAM is about 3,200 megapascals with a range of about 240 megapascals. So this is consistent with what we would expect. Now my age data had an average of 2,716 megapascals with a standard deviation of 7.84%. So it's much smaller standard deviation. These samples were each aged for 24 hours in liquid helium, which is at 4.2 Kelvin. And to give you kind of a bearing of how cold that is, 0 Kelvin is impossible to achieve. So 4 Kelvin is really, really low down there. So here is just a kind of condensed showing my control samples versus my age samples. The reported modulus shown here is the number that comes from the material safety data sheet for ULTRALAM. So you can see that my control were only 3% short of the reported modulus. But what I really want to compare is my control samples versus my age samples. And so you can see there is a decrease in the modulus of 17.69% for the age samples. Now, in conclusion, as a preliminary study, we've shown that liquid helium cryogenic aging leads to a decrease in the modulus of elasticity for ULTRALAM 3850HT. Longer age does not cause the modulus to change further. This is another study that we'll be looking into, as well as some other future work using more accurate sample measurements, the same test with another polymer, Lux, and also we want to investigate the possible time dependency of the modulus after aging. Thank you.